Hey everybody, Jason Sherman here. In today's episode of Zero to CEO, I speak with tech pioneer Nandan Nayampally. Welcome to the show.
Hey, thanks for getting us here, Jason.
No problem. And today we're going to be talking about unlocking the future of AI with breakthrough semiconductors. Very exciting, especially because AI is like such a hot topic. I mean, I'm running an AI startup, as everyone knows, and everyone's just talking about it and using it. So, what I want to ask you first is, how far back have you been working with AI in general that made you realize that you wanted to work in that kind of industry?
So I might start by saying uh, my junior thesis was in AI back in the day, but that's
That's cool.
way, way, way far away. But I've been in computation initially on the CPU side for the longest time. But really, it's maybe the last 10 to 15 years when you started seeing the intelligence building. Initially, it was intuitive computation, personalized computation, adding to intelligent computation. And
Yeah.
from a semiconductor standpoint, which is where I've been looking at it, you've been consistently growing. Hey, we're moving away from the traditional CPU kind of programmatic model or visual GPU model into something that is much more intelligent, and it needs a
Yeah.
combination of different types of things. So it's been a while, but the last
Yeah.
decade and a half have been particularly exciting.
Yeah, and as we know in the news, Nvidia has really kind of taken hold of this market,
Hmm.
and there's a lot of companies out there trying to create the next generation of semiconductors. I've been following that a lot.
Hmm.
It has to, I mean, as far as I can tell, it has a lot to do with data movement, right? Because you're talking about
Yep.
intelligence. It's not just information. It's a neural network. I mean, that's what AI is, and at the end of the day. So why is data movement so critical for AI to work better?
So if you think about what almost every AI action is it's building up on intelligence based on data, right? So data is fundamental to anything that has to do with intelligent operation, right? So it's going to be about moving data, um, playing with data, stirring it back, updating it. So it's really about data movement. And as you start seeing, especially neural networks start operating, it's about moving through different layers of computation, which is again data movement. And a lot of effort has been spent by these uh, computation pioneers, connectivity pioneers to see how do I minimize the amount of data movement because the amount is enormous, right?
Yeah. I mean, we're talking about like petabytes, probably even
Yeah,
even bigger than that, right?
that's
Because not terabytes, not gigabytes,
yeah, it's peta
especially
exa.
yeah. I mean, we're talking massive amounts of data. I think a good example would be scientists trying to parse a lot of data for a cancer treatment, for example, and
Hmm.
like DNA and stem cell research. I mean, there's
Hmm.
like billions and trillions of data points, right? So how do you
Exactly.
move that around? And so we're used to CPUs, like you mentioned,
Hmm.
chips, right? And and
Hmm.
and and now semiconductors are really kind of where things are going in that direction. They probably have been for a long time. But explain to people the differences between a CPU, a semiconductor, a chiplet,
Okay.
and how Moore's law has kind of a part of that. Like there's like a little bit of historical data there.
Really. So I think I'll keep it as high level as I can, right? So
Sure.
CPUs or central processing units are much more control flow based. So a lot of what is called uh, uh, hey, if this, then do that, or do this 100 times kind of activity that gets done on CPU. Obviously, I'm simplifying it, but that's the basis. Now, obviously, you can do a lot more through software, right? But it is always going to be limited by its flow of instructions, right? Whereas with GPUs or graphics, which traditionally came from doing same mathematical operations on large number of points, right? So obviously you can think of pixels, the same idea, but that's kind of gone into use for crypto and now for AI, where there's especially if you think about the brain, you're doing a lot of parallel computation, which lends itself to the neural network model. Now, if you think about what chips, chiplets, etc., are traditionally it was diodes and vacuum tubes, but that translated to solid state, which is semiconductors. You have originally it would be a whole CPU would be on one chip, and then you would go out and go to memory. So each chip would be in separate. Same thing with the GPU, right? And usually they'd have their own cards going through. Now, all of these things are very expensive operations and very power hungry operations. So as you
Yeah.
started going into mobility, right, laptops first, which were chunky giant suitcases, to very thin now MacBook Airs, and then more importantly, I think what drove that real change was smartphones.
Of
Right? For
course.
smartphones, it was truly the first personalized computation platform because it was customized to you. You were doing it rather than writing a giant website. You're getting an app that's customized to you, right? So that was
Right.
kind of a genius piece. But what you needed to do was to then combine a CPU and a GPU and a modem kind of connectivity on a single chip. That was called a
Yeah.
system on a chip or an SoC. And that is needed because you want to integrate all of that because that's how you get lower power operation. Right? Now, what's happened is that same concept has gone into uh, I can now build multiple, best in class components in what's called a chiplet and put them together on a bigger chip that gives you a lot more flexibility in what you want to do. And that's become the basis of what you see from AMD, Intel, NVIDIA to really start scaling and having different uh, types of products at the market very quickly.
Interesting. It's kind of like it's a customization of what is the tool going to be used for, and then
Exactly.
let's create a chip for that use case. That sounds very interesting because you're right. I mean, GPUs. I remember when I was buying really powerful GPUs years and years and years ago to do some crypto mining. Video gamers were really upset because we're taking away their use case,
Mhm.
right? And so and it's happening again today. Like it's
Yep.
hard for them to get the GPUs they want because people are still mining crypto, but now they're using it for AI because they're running their own versions of ChatGPT or DeepSeek on
Mhm.
their own computers at home with no internet attached to it, so it's more
Mhm.
private, and people are upset about that. So it sounds like there is going to be some new chips out there, chiplets that maybe people can use for specific use cases to kind of get away from the GPUs. Maybe that's what it sounds like you're saying in a sense.
So you're right, right? So I think part of it is even NVIDIA is kind of doing their own, right? So they have not just GPUs, but they have their own accelerators that go aside of it. What chiplets offer is for you to kind of build certain, um, I would call them to some extent Lego blocks. And then you can say, hey, I want a 2x that or a 4x that on the same package instead of
Nice.
having to build a 4x chip and then run a 2x chip and a 1x chip. So you have the flexibility to build out kind of modular solutions. Plus, then you can combine best in class from, let's say, along with my GPU, I want a neural accelerator and I want the best connectivity to connect to other things. And I can create my special solution that works for my data center, right? For my
Yeah.
types of workloads. So it's really about scaling um, customizable solutions for your workloads.
Yeah, it sounds interesting. And I remember growing up and in college and whatnot, learning about Moore's law and how chips get smaller and faster
Hmm.
every certain amount of years. It was, I think it was every year almost,
Hmm.
and it was just now it's you're saying you can 2x 4x a chiplet just because you need it to. That kind of bypasses Moore's law, doesn't it? It sounds like.
Yeah. So if you look at Moore's law, and I'm sorry I missed that on the first time around, Moore's law is clearly, I think, become a law, but it's kind of more of a statement that was made true for a while, which was every 18 months you double the size of the memory that you can put on die, right? And reduce the cost by half. And the assumption was the performance was going the same way. But over the last decade or so, Moore's law has been um, certainly trending downwards. And certainly the fact that you have twice the number of transistors available doesn't necessarily mean that you can use all of them because of the power challenges, right?
Right.
And the thermal impact. So, in fact, When I was at ARM's CTO, we used to say this concept of dark silicon because I can't actually use half the transistors on my chip because it's too hot and the package won't be able to handle it, right? The thermal impacts are pretty high.
You know,
So,
what I find interesting about this is that you're talking about the hardware side of things in a
mhm,
big way, and that's what we've been, I guess, circling around for like decades and decades is hardware getting faster, cheaper, more
mhm,
performant. And then I realized something in the last several years when, AI really became mainstream in a way is software can overtake hardware in a sense because we're still using the same old desktops, same
mhm,
old laptops, same old smartphones, but software is getting better and better and better, which is improving my production, my productivity, my
mhm.
efficiency. It's reducing my risk because it's doing a lot of the work for me, so I don't have to spend my time and then find out, oh, that didn't work. I wasted all that time. No, the AI wasted its time, and I can speed up my market delivery. Usually, I would have had to get a faster computer, better
Mhm.
smartphones, faster GPUs. I don't have to anymore. Is that kind of like part of how the market is looking right now?
So I think what you're seeing is like there's a constant innovation on all fronts, right? So if I make my app work really well on an older phone,
Right.
I get more subscribers, right? So there's innovation that's going to come from that standpoint. If I can make my software run faster on an older machine, I have a much larger install base. I don't have to wait for them to get the new hardware. So there's always that, right? But there are some tasks that you keep coming up with that need more hardware. So
Right.
what we're seeing right now, and what you talked about chiplets, is one more um, variation of seeing it is from a whole system or a service level, you have to think about how to optimize everywhere, right? And you're going to see these giant steps that you'll get. For example, right, DeepSeek, right?
Yeah.
DeepSeek basically was a different algorithmic view that took like maybe a couple of orders of magnitude off the level of compute required to do the same thing that the LLMs were doing.
Yeah.
Now, does that mean that's over? No. What that means is now I can get more accuracy with less compute. So these models are going to get larger because I want more accuracy.
Of course.
And that's going to drive that cycle all over again. So I would look at it as, hey, what started off as a giant mainframe that took a room that fits in your pocket today, right,
Insane. Yeah.
is the same idea that you're going to keep going through. You're actually seeing devices that can go inside you, right?
Right. We're
And
talking about nanotech eventually is going to be in our
exactly.
bodies, and we're going to be doing a lot of the wearables, and it's not
Yeah.
going to be I mean, I'm waiting for the day when we're no longer tethered to a computer or a phone, and it's just we are the device essentially, right? And is that where you see the future going?
So if you think about AI in general and what is considered AGI and or the myth of AGI in the future is really can you make yourself better with things that are already available in the collective effectively, right? And for that, you have to connect. Today, the device that you have is your connection, and that at some point be more endemic. Don't know, but you're already seeing some of that. Can I actually have a device in me that translates my brain waves into words or actions? Possible, but certainly what I see in the short to medium term is the ability to build much more effective services to improve lives, right? So we were talking about, for example, getting your eyes cataract analysis done in a village in India, for example, right?
Yeah.
I can actually use my smartphone to characterize most of that, and if I have a connection, it can go back to the main center, and you get the feedback very quickly. That changes the way healthcare can be delivered, right?
Right.
So that's just an
and
example.
and
There's
there's so
plenty
many and
more,
there's so many
so
more
many more
examples like that
examples of that.
that I've been researching. I mean, you guys are doing a lot at Baya Systems. Tell everyone like what you guys do and where they can find out more information about you.
Great. So Biosystems is focused on data movement within a chip or a system on a chip or across multiple chiplets, right? So if you think about data movement, it can happen at kilometer level, you got fiber going undersea. You've got it at meter levels that are within the rack. You've got it at millimeter level across the PCBs, and then you've got a nanometer level on chip, right, on die. So we focus on the nanometer level data movement. And what people always get enamored by is the computation. Hey, there's a CPU, there's a GPU, the neural processor. But really, there are lots of these widgets that you put on the die that have to communicate very efficiently and move data across them. And that's what we do. How do we make that easier for customers
Interesting.
to build chips, and also how to make it easier for software to run on it?
Very cool. And they can check you out at bayasystems.com.
www.bayasystems.com.
Guys, check it out. It's the future. If you have something to do with semiconductors, data movement, anything, you are the man. You know all about this. So definitely reach out to Nandan, guys. Bayasystems.com. Hope you guys enjoyed the episode, and we'll see you guys in the next one.